Welcome to this video lecture on problem solving and Python programming. In this session, we will begin with Unit 1, Computational Thinking and Problem Solving. This unit is very important because it introduces the fundamental thinking process which is required to design correct and efficient computer programs. Next, Introduction. Problem solving is the backbone of computer science and programming. Before writing any program, we must clearly understand the problem and logically plan the steps which is required to solve it. Computational thinking enables us to break the complex problems into smaller and manageable parts and approach them systematically. Next one is fundamentals of computing. A computer is an electronic machine that accepts data as input, processes it using a set of instructions, produces output, and stores the result for further use. The main purpose of computer is to transform a raw data into meaningful information that can support decision making and problem solving. The next, computational problems. Computational problem is a problem that can be solved using a computer through a sequence of logical steps. Such problems must have clearly defined inputs and a processing method and expected outputs. So examples include calculating marks, sorting numbers, or finding the shortest path between two locations. The next, the types of computational problems. The computational problems can be classified into four major types: decision problems, search problems, counting problems, and optimization problems. Decision problems requires a yes or no answer, such as checking whether the number is even. Such problems involve finding a valid solution, such as locating an item in a list. Counting problems determine the number of possible solutions. Then, optimization problems focus on finding the best solutions among many alternatives. The next, problem solving. Problem solving is a structured and logical process. It begins with understanding and defining the problem clearly, and followed by designing a solution and finally implementing the solution as a program. A systematic problem solving approach helps to reduce the errors and improves the program efficiency. Next, problem solving techniques. To express the solutions clearly and effectively, several problem solving techniques are used: algorithms, flowcharts, pseudocode, and programs. Algorithms provides a step-by-step solution, whereas flowcharts represents the logic visually, and pseudocode expresses the logic in English like statements. Programs implements the solution using the programming language. An algorithm is a finite set of clearly designed steps used to solve a problem. Each step must be precise and unambiguous. A good algorithm always produces correct results for all the valid inputs and terminates after a finite number of steps. To understand these concepts better, let us consider the simple example. The problem is to find the sum of two numbers entered by the user. Though it is simple, this example clearly demonstrates the complete problem solving processes. This algorithm is for finding the sum of two numbers is as follows. First, start the program. Next, read two input values from the user. Then, add the two values and store the result. Then display the sum as an output. Finally, stop the program. Each step follows a logical sequence. The same solution can be represented using pseudocode. We begin by reading two values. We then calculate their sum and display the result. Pseudocode helps the programmers understand the logic clearly before converting it into any programming language. A flowchart provides a graphical representation of the same algorithm. It begins with the start symbol, accepts input, performs the calculation, displays the output, and then ends. Flowcharts are especially useful for visual learners and for explaining logic during discussions. So, the next important concept is control flow. Control flow determines the order in which the instructions are executed in a program. So, sequence executes the statements one after another, whereas selection allows a decision making based on some conditions. So, iteration enables the repetition of steps using loop. These control structure forms the core of an algorithm design. The next is importance of algorithm design. Designing an algorithm before coding offers many advantages. It improves clarity, reduces logical errors, simplifies debugging, and enhances the program efficiency. Well designed algorithms lead to reliable and maintainable software solutions. To conclude, computational thinking and the problem solving are essential skills for every programmer. So algorithms, pseudocode and flowcharts helps structure the solution clearly before implementation. Mastering these concepts provides a strong foundation for learning Python and advanced programming techniques. Thank you.